Okay, we were cut off. Let's see if we can pick up with number 6 again. Number 6, you've got X, Y, and Z, all three angles. They're inscribed angles. Their vertices are on the circle itself, and they're all inscribed in the semicircles, one on one side and two on the other side. So each of those angles, X, oops, got things off kilter there, didn't I? Okay. X and Y and Z are going to all be 90-degree angles. Okay, now let's take a pause and work the last three. Okay, we were cut off. Let's see if we can pick up with number 6 again. Number 6, you've got X, Y, and Z, all three angles. They're inscribed angles. Their vertices are on the circle itself. And they're all inscribed in the semicircles, one on one side and two on the other side. So each of those angles, X, oops, got things off kilter there, didn't I? Okay. X and Y and Z are going to all be 90-degree angles. Okay, now let's take a pause and work the last three. Okay, we're ready to pick up on these last three for this page. As I look at number 7, I'm noticing that 76 degrees is an inscribed angle, and that the arc that it intercepts would be 2 times 76, so that's going to be 152 degrees. Now, if you'll look, then, let's see, let me use a different color. If all that's 152 degrees, the rest of the circle is divided up evenly, because you see these congruent chords? The congruent chords have congruent arcs. So if there's 360 degrees in my circle, and I've accounted for 152 degrees over here in red, that leaves 208 degrees to be divided evenly between this purple arc and this purple arc. So 208 divided by 2 is 104. And then I would take half of 104 to get Z, because you see the vertex is on the circle. Okay? And then my X over here is an inscribed angle. Let's see if I can get another color up here. My X is inscribed, and the arc that it intercepts is that 208 degree arc. So it's going to be half of 208, so it's going to be 104. Okay? Now on number 8, let's see. We've got these congruent arcs, or actually congruent chords, so we've got congruent arcs. So if this arc is 80, then this arc is 80, which is going to make my X arc 80. And Y, there's the vertex on the circle, is an inscribed angle, so it's going to be half of the arc, so it's going to be 40. There's 360 degrees in my circle, and I've accounted for 240 of those degrees with 3 times 80. So that means that the arc that I'll mark in red is 120 degrees. Therefore, Z has got to be half of that, or 60 degrees. Okay? Now, number 9, what I'm observing is this is an inscribed angle. And please know that there are a lot of ways to approach these. If I were to sit down and do these tomorrow again, I might do them a totally different way. I'm just, the way that hits me immediately, that's just the path that I take. This angle here that I've marked is an inscribed angle, and it intercepts a 100-degree arc, so it must be 50 degrees. But since I have parallel lines, we haven't seen those in a while. I have alternate interior angles congruent, so X must be 50 degrees. And X, you know what? Is that Y? I can't read that very well. It's really smudgy. We're going to say that's the Y. My X degree angle here is inscribed, and the arc that it intercepts is Y degrees, or what I'm calling Y degrees. So I would double that to get 100. Double this 50 to get 100. So now I have a large portion of my circle. I've got 100, 290 degrees out of the 360. So 360 minus 290 is 70 degrees. So that means that this little arc here is 70, so the angle in there is going to be 35. Okay, we're on the page 359 of the packet now. So if you would like to stop the video and work 4, 5, and 6 at the top of the page, this would be a good time for you to do that. All right, number 4, we've got an exterior angle that has been made by 2 tangents to the circle. So we know that that exterior angle, that the measure of angle 4 is going to be 1/2 260 minus the second arc that particular angle cuts off on the circle. Well, since the whole circle is 360 and this large portion is 260, then obvious my little zigzag circle in there is going to be 100 degrees. So I'm going to have 1/2 160 or 80 degrees. So angle 4 is 80 degrees. Okay. On number 5, excuse me, again, I've got now a tangent in a secant that's created angle 5. So it's going to be 1/2 the 170 degree angle minus the 80 degree angle. So that's going to be 1/2 of 90 or 45 degrees. And then in number 6 over here, you see that we've got a total of 280 degrees accounted for. 120 on top, 160. So that's 280 degrees. So that leaves me 80 degrees for that little arc right there. So angle 6 is going to be 1/2 160 minus 80. So it's going to be 1/2 of 80 or 40 degrees. Okay? So it's time to pause again and work 7, 8, and 9. Okay, on number 7, we have 2 chords intersecting inside the circle. And when we have that, an angle formed, in this case we have a 75 degree angle formed. The 75 degree angle is 1/2 the sum of its arc, which is 100, and its vertical angle's arc, which is x. Now if I multiply both sides by 2, so x is going to be 50. Okay, number 8 is like number 6 above. That outside angle that's 30 degrees, I'm going to have 30 degrees equals 1/2. Now I'm outside, so I'm going to subtract my arcs. So I've got an x arc and a 70 arc. If I multiply both sides by 2, and then add 70 to each side, my x is 130 degrees. And then lastly, we've got a problem like we had on number 4. We've got 2 tangents to the circle. So I've got that the 58 degrees equals 1/2 the 360 minus x angle minus the x angle. See, this was the 360 minus x, and then this is my x. I'm going to multiply both sides by 2. Now, once I do this arithmetic, I can combine those x's. It's going to give me 360 minus 2x. So I need to subtract, bring 2x over here. So I need to subtract 116 from 360, 244. So x is 122. Okay, guys, I'm looking now at this large diagram that has 10 angles missing. You know, that could be a test in and of itself because it's got so many different types of angles and arcs and so forth in there. So that could be half the test if I wanted it to be. Let's go through carefully and find these missing angles, okay? Let's mark up the drawing with what the directions tell us. BZ is tangent to circle O. All right, now if BZ is tangent and it's circle O, that means O is the center, then I'm already knowing that I've got a right angle there and a right angle there. So let me just come over here. And as we mark these things, we may can knock out some of these answers. Okay? Now, if you see angle 9 is not going to be 90 degrees. We already know that because of a radius going to a point of tangency, so that creates a 90-degree angle. Okay? AC is a diameter. Arc BC is 90. Now, if arc BC is 90, isn't angle 1 a central angle that intercepts that arc BC? So angle 1 is going to equal 90 because a central angle is equal to its arc. Now let's see if we can use that for any other information yet. Maybe so, but I think we just should go ahead and just proceed. Little arc CD is 30. Now just from C to D, that little bitty piece is 30. Arc DE is 20. So that little piece right there is 20. Draw your own large diagram so you can write arc measures alongside the arcs. It really does help when you blow up the drawing. Okay, let's see if we can figure out anything about angle 2. Just simply because I've already got angle 1, so let's look at angle 2. Now, it looks to me like angle 2 down here is an angle that is inscribed in a semicircle. And since that's the case, angle 2 is going to also be 90 degrees. All right, angle 3, okay, angle 3 is over here, and it's an inscribed angle. See, where's the vertex? And its intercepted arc is from C to E. So its intercepted arc is 30 plus 20, or 50. So that's going to make angle 3 25 degrees. Okay? Let's see, angle 4 over here is another inscribed angle. See how its vertex is on the circle? And the arc that it intercepts is this arc from A to E. Well, notice that this lower part of my semicircle from A to E to C, that's going to be 180, and I already know that from C to E is 50, so that means this AE must be 130. So angle 4 out there is an inscribed angle that intercepts that 130 arc, so half of 130 is 65. Okay, angle 5 is inside the circle. Now remember, ask yourself, where is the vertex? Angle 5 is made when two chords intersect inside the circle. So angle 5, let's see, so we'll do some scrap work over here. Angle 5 is going to be 1/2 the sum of its arc. Well, its arc is the 90-degree angle back here. So its arc and its vertical angle's arc. Well, here's its vertical angle, and its arc is the 20. So 1/2 of 110. So I'm going to have a 55-degree angle for number 5. 5 and 6 form a linear pair. So I can just say for angle 6, 180 minus 55. And that's going to be 125. Okay. Angle 7, which currently I have totally lost. Okay, it's out here because I had covered it up. There's angle 7. It's an exterior angle aiming toward the circle, so it's going to be 1/2 the difference of its arc. Let's see, its arc is the 20. And its second arc is out here. It's going to be from A to B, so that's a 90-degree angle. So I'm going to have 1/2, or rather a 90-degree arc, I'm sorry. So I'm going to have 1/2 of 70, so that I'm going to have a 35-degree angle there. Excuse me. Okay, angle 8 is like angle 5 was a while ago. See how it's inside there? So angle 8 is 1/2 the sum. Okay, its arc is this arc back here, that 90-degree arc behind it. Again, this arc here. And then its vertical angle's arc is this 30 degrees here. So it's going to be 1/2 of 120, or 60. Then angle 10 out here is one of those angles. Again, look, its vertex is on the circle, and it's made by a tangent and a secant, so it's going to be 1/2 of its arc. And let's see how far out its angle comes. So its arc is going to be 90 plus 30, or 120. So 1/2 of 120 is 60 degrees. So that should be our measures for 1 through 10, and that's a really, really good little exercise there to help us figure those out. Okay, and I'm going to stop for just a second in case you need to check those before we look at 11 through 14. And we might not even look at all those, just a couple. But I'm going to need some more space, so before I erase that, if you need to check that or stop the video to look at where things come from, feel free to do that. Okay, I'm going to go to 11 now. You can always rewind this and look at these again. Okay, I'm at 11. So 11 says that the measure of arc RT is 80 and US is 40. We have to find angle 1. Well, the measure of angle 1, again, it's inside the circle. That that hasn't been given that that's the center of the circle, and obviously it's not, or I wouldn't have an 80 and a 40. I'd either have two 40s or two 80s, but that's beside the point. So my angle formed from those two chords is 1/2 the sum of its arc and its vertical angle's arc. So here I've got angle 1 is 60. Now number 12 is not going to build on number 11. Okay, it's going to have its own. I'm going to erase everything. We're going to start with it fresh again. Okay, this time RU up here at the top is 130, and TS at the bottom is 100, and they want angle 1. This is where I called. You remember I put the Y in and I'd solve for Y. Y is 1/2 100 plus 130. So that's 1/2 of 230, which is, of course, 115. So if Y is 115, Y and angle 1 are a linear pair. So I can subtract that 115 from 180. So I get that angle 1 is 65 under those conditions. Okay? Number 13. Angle 1 is 50. Now they're getting us some info. Whoops. They're getting us some info inside here. Angle 1 is 50. RT is 70. And US we're looking for. So this time we are going to use the same formula, but our unknown, instead of being the angle, is going to be the arc. So 50 is 1/2 70 plus x. Multiply by 2. And then let's subtract the 70. X is 30 degrees. Okay. And a last one here. We've got angle 1 now is 52. And I've got US is 36. We have to find RT. Same kind of thing. The angle is 1/2 its arc plus the vertical angle's arc. I don't know why that's not turning out really well. Subtract 36 from each side, so 104 minus 36. Notice I'm not grabbing a calculator. $68. My pen must be going out on me. Okay. All right, that's some good practice as well. It'd be a really good idea for you to pause now and do 15 through 17 and see how you can, what you can do with those. And I'll wait for you. Okay, CT is 110. You know what? I'm going to have to put my pen in for about 15 seconds. CT is going to be 110 and BT is going to be 50. We have to find that exterior angle. Now remember, that exterior angle is created by or made by a secant segment and a tangent going to the same circle from the same exterior point. In this case, the point is A. Let's see if this will help. So CT is 110. Well, it's not helping, is it? Very, very strange. Let's see if my finger will work. There we go. That's better. Okay, and BT is 50. And we have to find this angle. So for number 15, we're going to have that the measure of angle A is 1/2 110 minus 50, which would be 1/2 of 60. So we're going to get 30 for angle A. Okay. Next one. And again, you can pause those if you need to. Rewind, whatever you need to do. Number 16, now A is 28. BT is 46, and now we've got to find CT. So now 28 equals 1/2 x minus 46. So 56 equals x minus 46, or x is 102. Excuse me. The more you practice these, the more these formulas are going to stick in your head, and it'll be helpful to you. Okay, now A is 35, CT is 110, and we have to find BT. So 35 is 1/2. If you'll put that big number first, the angle or the arc furthest away from my angle, if you put that one first every time, you won't have to worry about absolute values. So x equals 40. Okay? All right, take a break now and see what you can do on 18 through 21. While I wait for you, just pause the video and we'll work those out. On our next group, it tells us that PX and PY are tangents. So we've got two tangents extending to the circle from the same exterior point. It's going to be the same formula that we used above. X, Z, Y. And I see those three letters right there. That tells me that we are talking about the major arc back here. 250 degrees. That arc there. And we want to find angle P. All right, there's 360 degrees in the circle, so my minor arc would have to be 110. So angle P, why I put 9 there, no one knows. Okay, the measure of angle P is 1/2 250 minus 110. So we're going to have 1/2 of 140. So it looks like we're talking about 70 degrees there. Okay. Now let's just shift it around some and see what 19 wants us to do. On 19, XY is 90. We have to find P. So 360 degrees minus 90 means I've got 270 back here at the back. So the measure of angle P is 1/2 270 minus 90, which is going to be 1/2 of 180 or 90 degrees. So angle P would be a right angle if this was the situation. Now I'm looking at number 20 right now, and I'm seeing in terms of t. So I'm going to have in my answer this time the variable t. I'm not going to get a whole number or just a nice rational number. I'm going to get an algebraic expression for my answer. So let's see what type of information they're going to give us. And I'm going to clean all that off of there because sometimes students get nervous when you have something like that. So let's see if we can make it better. Arc XY is T. Okay. Then the measure of XZY would be, okay, the rest of the circle then would have to be 360 degrees in the circle minus the T, wouldn't it? So that's 360 minus T. And angle P would be, okay, angle P would be, the measure of angle P would be 1/2 the 360 minus T minus the little t. So I'm going to have the measure of angle P equals 1/2 360 minus 2t. Now if I distribute my 1/2, I'm going to get 180 minus t. So in terms of t, angle P is 180 minus t degrees, if we want to be fancy. Okay? And 21. Angle P is 65. Find the measure of XY. Okay, so I don't know what XY is. Why don't we just call it X? Or you know what? Based on what we just did, let's call it T. So XY is T, so that means the back side is 360 minus T. Okay? So I'm going to have 65 equals 1/2 360 minus T minus T. Or 65 times 2, to get rid of the fraction, I'm going to have 130 equals 360 minus 2t. Or 2t equals 230. So t is 115. Yeah, and that's what xy is. Xy is t. So 115. Okay? All right. There's some challenge problems below. I'm going to pause for just a second so I can raise my video up or my paper up without making such a mess. So I'm going to hit this on pause and I'll be right back. Okay, take a minute to look at 27 and 28. Don't be intimidated by them. We did a challenge problem just today in class that was similar to it. And so you should be able to handle that okay. Okay, so take a minute, pause, and see what you can do with them. Okay, I'm going to call this point out here P, because I need to be able to reference it somehow. Now, notice what P's relationship is to the big circle. So that means pretend like the little one's not even in there. Then you would have P is a inscribed angle, and its intercepted arc is C. So that tells me that the measure of angle P is going to be 1/2 of C. Alrighty. Now, read the directions. I didn't do that. And I should have write an equation involving A, B, and C. And that means that A, B, and C are going to be in my answer. I'm going to have an expression, or I'm writing the answer in terms of A, B, and C. So let's see how this falls through. Now we're going to focus on the little circle and not the big circle. If I'm focusing on the little circle, then angle P is an exterior angle that's extending to the circle. So for angle P, I need to say that's going to be equal to 1/2 B minus C. I'm sorry, B minus A. That doesn't even look like an A, does it? Let's make it better. So if you notice, I've got angle P equal to do two different things. So if angle P, I'm going to use my transitive property, angle P is equal to two things, so let's set them equal to each other. 1/2 C is 1/2 B minus A. If I multiply both sides by 2, C equals B minus A. There is an equation that involves A, B, and C. All right. This 28's interesting as well. We want the ratio x to y. Now remember that if I'm going to use equations, I'm probably not going to see this type of notation in an equation. But x to y in an equation, I can see it x divided by y. So we're probably looking at coming up with an equation in which we solve for x over y. So let's see what we can do with this. Let's look at angle N first. And angle N, I'm going to do my work down here at the bottom. I think I've got plenty of room. This angle N out here is made by two secants extending to the circle. So I've got this arc and this arc. So let's see, angle N is going to be 1/2 x minus y. Okay, that's good. I don't know if I'm going to hit a dead end going this way or not, but I do know that's true, so it's probably going to be helpful to me. Now look at 2n. 2n is inside the circle. It's made when two chords intersect inside the circle. So 2n is 1/2 the sum of its arc and its vertical angles arc. Okay, so far so good. Now, if I want to go ahead and divide this one through by 2 or multiply it by 1/2, same thing, then I'm going to have that n equals 1/2 x minus y. And I'm going to have here that n equals a quarter x plus y. Okay, let's see if I've got that right. Okay, Now, what I'm going to do, I'm going to set these ends equal to each other. So I'm going to have 1/2 x minus y equals 1/4 x plus y. I'm going to get rid of those fractions, so I'm going to multiply everything through by 4. And here, that's going to give me a 2. So I'm going to have a 2x minus y equals x plus y. Okay, now remember, my goal is to get an x over y, so I'd better start doing some pretty quick ciphering. Let's distribute the 2. 2x minus 2y equals x plus y. I'm going to subtract x from each side. And then let's add 2y to each side. Okay, x equals 3y. Now, do you see? If I divide each side by y, I'm going to have x over y equals 3. Or it could be 3 to 1. So my ratio is going to be 3 to 1. The reason I'm pausing is I haven't done this problem in a couple of years. I don't remember that 1/4. It could be that I just forgot it. It could be I've made a mistake. So I'm going to spend some time looking at it myself.